Yeah, thanks for joining this talk. It's quite a good present considering that we are almost in the last session. I mean, we are in the last session, or actually this is almost the last talk of the summit. I want to introduce to you something that I'm really excited about, which is stream service that Huawei will launch. It's actually already in, let's say, beta phase, so it will be launched this month. As you can imagine already, the service has a deep connection with Flink. It's actually based on Flink, hence the reason why we are announcing this in this very nice summit. Before I proceed, I want also to emphasize that I should not get the credit for this, as this was actually the work of many people building this service, and particularly I would like to emphasize Xi Jinkui, who should have been present here, but unfortunately, visa procedures can take a bit more time than sometimes we want. But anyway, we should give credit to all the people behind this service. Okay, so before I actually introduce the service to you, I want to say a couple of things about Huawei. Do you know Huawei, first of all? Okay. Okay, good. Do you know that Huawei does also something besides telco equipment? Who knows this? That we do more? Okay. Probably the guys that raise the hand know that we do also mobiles. But the final question is, how many of you know that we are actually in the IT business, in the cloud business, and basically we are a cloud public provider, and we are building, among others, big data services on top. I mean, this is, I guess, something that is not so well known, so that's why I wanted to give you a couple of details about this. Of course, that in order to build a cloud, in order to do innovation in the area of cloud or big data services for that matter, and actually not just this, but also if you want to build better connectivity for the mobile, better equipment for the telco operators, better, a better connected world, which is actually the motto of Huawei, you need huge investments in innovation. And actually, Huawei is investing a lot of money to continuously improve the technologies. And more than this, we have also something, I would say, quite unique in the sense that the innovations or the way we do innovation is not necessarily limited just to in-house innovation that we keep for ourselves. So we are opening up, or we are, let's say, in the process of opening up to work more and more with the open source communities. That's why we are also here to join basically the Flink community. But in addition to this, we are also participating in many industrial alliances, open alliances, standardization efforts, and all these kind of things in order to, most of the time, do the innovation together with the customers. This is a model that we call joint innovation. Okay. It should have been on the other side, sorry for that. Okay, we are a global company, but we have, of course, a major presence in Europe. I wanted to emphasize particularly the presence in Europe, as we are at the European Summit of Huawei. We have actually more than 1,500 people working in different areas of research and development. A smaller number are focused on the cloud-related businesses and big data businesses, but we are actually aiming to grow this number. So basically, the cloud business is something that we have started more recently, and we are pushing to increase the number of researchers, for example, that work in order to innovate and better offer better services. So in case you are interested in anything related to cloud and big data, you can consider us. We have quite some nice research labs. So with this being said, I wanted to also give you a small overview of the cloud before we actually dig into the cloud service. As I mentioned before, Huawei has this openness in mind when it starts to think of how we should build everything related to the IT services. So because of this, you will see actually in the middle of this picture that even the cloud native infrastructure is also something that emerged from open source. Maybe some of you are already familiar with OpenStack. So this is actually the virtualization platform based on which we provide the management, and then on top of the management, we have various options that we are building in which we can expose to our customers the computation and the storage that basically a cloud would provide. Another interesting thing that, that I want to share is that actually Huawei is building the cloud as an end-to-end solution. So we have basically the capabilities to build in-house the data center, so everything from the chip upwards. Then on top of this, we build the virtualization. We do a lot of enhancements and also contributions in OpenStack for this matter. We have our own management tool, which is Manage One or Fusion Manage One. And on top of this, we have a big data distribution that offer big data services to our customers. Obviously, the talk is related to this specific part of the cloud, which is basically the stream service that we have developed to run on our cloud and then to serve all our customers that require real-time processing. So the agenda of my talk will be focused on giving you a bit of a feeling of how is this service being composed, what does it contain, how we manage actually to put Flink on the cloud and offer it as a cloud service. And then finally, I will conclude the talk with a couple of thoughts of, what can be the next things. Some of them can be, or hopefully will be taken by the community. Some of them we will just do in-house, particularly if we don't find necessarily the support in the community for them. But this, I think it's an always open discussion. So a cloud service, what is it? I mean, maybe some of you are already familiar with this. The idea of offering cloud services would be that you get rid of everything that is annoying when you want to do some, in this case, data analytics. So basically, the service takes care for you about, how do you manage the cluster, for example, how do you install or deploy, for example, Flink jobs, or for that matter, HDFS or Zookeeper, or all these services, all these big data services that are more or less dependent on your application. More than this, you don't have to provision from the beginning all the resources that you need. Of course, cloud offers us the possibility to have pay-as-you-go model. And on top of this, you have the option to focus on your business scenarios rather than all the other things that I just said. So in terms of usability or how easy it is actually to use the service, Perhaps you all got a feeling in these 2 days of talks that the community is very proud about this Stream SQL feature that Flink actually started to announce in the summit last year, but it actually continued to develop it over the last year, and then now we see different features that are exposed based on this service. I want to emphasize that this is indeed something extremely useful because it actually goes hand in hand with this concept that the cloud brings, which is how easy it is to use the service. Because now such a stream service is not limited just to the people that have the knowledge on, programming Java or Scala or building an optimized, for example, or a correct stream application directly based on the data stream API, for example, but it can be actually available for everyone that can write SQL queries and the like. So I want to really emphasize that this is actually an important milestone in the lifetime of Flink, and it's very useful that we have this. Okay, so the menu. As you can see, it's launched at this point in China. This is something that you can get from the slides. It is launched together with several of other big data services that we are developing. Unfortunately, we cannot present all of them in this talk, but if anyone is interested, of course, we can discuss more about the other big data services. But one of them, which should be highlighted with a small dash line there, is the stream service, which is based on Flink. Now, here on this slide, you have a couple of snapshots of what you can get when you would start using such a service. Of course, you get metrics with respect to the usage and with respect to the cost that this resource usage incur. That would be the circle that you have there. That's the money that you have to pay for different parts. And down here, maybe the ones that are using the Flink console, the Flink web portal to see the deployments and the like, can see that this is actually something that comes from Flink, basically monitoring the deployment and the like. In addition to these things that you might expect, what we have done on top is basically to expose an SQL client, if you want, where you can develop your analytics. So that would be the thing that you see on your right. This is basically the easy way that I have mentioned in which you can actually construct the analytics, and then with a click of a button you deploy it and you have a continuous query that would run this for, how much time you decide to actually keep the query. So for the ones that are not familiar with how an SQL client would work on top of this Flink SQL, the idea would be that once you define this query, the SQL feature that you see on your top right, that's actually the Flink table that would compile the query, and basically the idea behind is that you get the equivalent data stream or the data stream program that implements the logic of the query. This is afterwards passed to the deployment client that would communicate with whatever cluster management tool you have in order to get the necessary resources in order to deploy the query. This is exactly what's happening also in the case of the cloud. So once you have this query that you have defined, it goes to the deployment client, it's compiled, it's optimized, and then you have this deployed in the cloud. The major difference is that, of course, things will be run in isolation because you don't want the query or the application to be run, with users that, might access your data, or, all these security constraints that are solved by virtualization and by having things containerized. So after you have this query deployed, of course, you have the option to just submit data to your analytics service and then run the computation. There are actually multiple use cases that would benefit from such a service. The first thing that should come to our mind is actually the IoT, or the IoT scenarios, because you can imagine vehicles that, for example, send different data to the cloud service for, analytics related to traffic monitoring, to, optimization of path, and all different use cases that all the use cases that we can name now, or all the future use cases that will be built once these kind of platforms will be in place. In addition to this, of course, you have the option to build pretty much all the applications that you saw already. You can build fraud detectors, you can build outlier detectors based on this service. It's everything that you can expect from a stream service. Now, with respect to how to build this, of course, you need to define three things. First would be the input, like where your data comes from, the output, where do you want to put the data, what do you want to do with the result, basically, and finally, what is the actual query. Now, you will see here that our default message or event management queue is not necessarily Kafka. It's something that is like Kafka, but a bit more optimized. We call it this service, a distributed ingestion service. Once you have the input and the output, as I said, you can just define the query and run it. Now, with this being said, I want to go a bit more in depth with respect to the architecture options and the design principle that are behind this service. And what I would like to highlight is that this service was built having in mind to be cloud native. So that means, of course, that we support continuous integration and continuous development. Obviously, this is something extremely useful, particularly if you depend on something that comes from the open source community, which will have continuous releases, continuous bug fixes, and the like. We want to have kind of like a microservice architecture, so that means that you should have a REST API on top of pretty much all the components, such that, for that matter, you can expose to the clients this API in order to monitor, to control the resource usage, to control the deployment, all these kind of things. You want to have isolation, as I mentioned before. Users should not be able to access other user jobs. And finally, you want to have reliability in the computation and responsiveness. I was hesitating a bit because I was not sure which one of these I should say first, because actually both of them are important. So I had a bit of a confusion in my mind which one should be mentioned first. Of course, you want to have resiliency because, if you put things on the cloud, or if you do whatever analytics, you don't want to lose data, you want to be online all the time, and you want basically to, let's say, have some sort of a trust that you are paying this money in order to get a continuous service. In the same time, you want to have responsiveness because a lot of the use cases, particularly from the IoT, depend on having a very, for example, very low response time, or they have very tough performance constraints with respect to the latency of the processing and the like. So, given this, actually, a lot of our efforts are going into optimizing the overall pipeline, and that implies, of course, doing various optimizations at different stages in order to increase the responsiveness of the service. Just to give you an example, if you think of the IoT scenarios, a lot of them are actually having requirements at the millisecond level in terms of responsiveness. So if someone would build such a service based on your cloud service, I mean, you don't want to violate that SLA. I mean, you really have to deliver that. So both of these, and of course all the others, are extremely important, and it's something that we focus a lot on. From the point of view of the architecture, it's basically a modern architecture in the sense that is event-driven. You have AKA for message to implement this message-driven architecture. We have native for the internal communications between the components. And then, of course, you have Jerkins for continuous integration and development. And yes, on top of that, you have the RESTful endpoint based on which basically the users can interact with the service. Now, in addition to implementing the service per se, another important aspect is, of course, the monitoring part, or as it is referred, for example, in the internal development of Flink, the metric module. Because first of all, you want to know very precisely, if possible, how much resources you have consumed. This is important both for you in order to have a fine-grained control on how many resources you allocate, but also from the point of view of the billing, because you really want to pay just for what you are using, not also for something else. An additional thing that comes with this metric monitoring is the scaling part. Now, for those of you who, let's say, work a lot with the maybe internal part of Flink, you know that Flink cannot necessarily be scaled dynamically. We saw some of the presentations, for example, from the platform of Data Artisan, that you can do some sort of scaling in the sense that you do a save point, you kill your application, and then you might scale it to some different, with a different resource allocation. However, in the cloud, it's actually a question. Do you want this, or do you want to have something more smooth? I mean, if you want to throw more computation to your analytical query, do you want to kill the previous query and deploy a new one, or it would be more useful to have something that works continuous? If the answer goes to a continuous scaling up and down, then this is actually a call to the community that there should be more efforts towards this dynamical scaling of the Flink core. There are some of the other, for example, streaming engine that already offer this. So this can be actually something that the community, the Flink community, can learn from the other communities of how to do this kind of scaling. Okay. We have discussed the monitoring, we have discussed how you deploy the application. I wanted also to highlight another thing which is related not to the SQL but with the rest of the Flink framework. You saw many of the applications and the use cases that were presented these days that are, for example, not necessarily built on SQL, or for that matter, use features that are not yet available in SQL. Now, in order to tackle this kind of use cases, the first thing that we have done was to enable users also to, just run their Flink program. So for that matter, you can develop on the data stream or dataset API, and then, instead of submitting your jar to potentially a local cluster, you can just use the cloud service to run the Flink job. But an additional learning that I would claim it's useful for the community, if we think that the usefulness of the SQL is that it enables such a service to be used by a broader range of individuals, in that case, I think we should consider of exposing more and more of the basic functionality that makes Flink such a good platform via this SQL interface. Because if we manage to do this, then the process of development for more and more people would be reduced, which basically reduces the cost to develop. It can grow the community, it can grow the use cases that we have on top. So I think this is an important aspect to consider in the future. Just to give you an example, there are, for example, graph languages. I mean, they are not SQL, but there are languages to construct graph analytics. What should be our take on that? Should we have two kinds of languages, or should we go maybe towards a unification? I'm not sure necessarily it's possible to extend SQL to cover, for example, full graph processing, but maybe some middle point. Okay, I want to finish the presentation by giving you a couple of thoughts of where can we go from here, both with the cloud stream service as well as us as a community. One particular thing, as I focus so much on these stream SQL capabilities to develop the analytics, is related to the cost. Basically, for those of you who know how this transformation from an SQL to an actual deployment, how this is being done, Flink uses CalSite in order to get an optimized query plan, and this optimized query plan is then converted into a specific implementation. Now, at the level of CalSite, in order to get the query execution plan, you are building actually multiple plans, and you associate some costs with each of them, and then you, of course, will select the one that offers the best cost. However, this is at the logical level. So basically, the costs that are associated at the level of CalSite are not necessarily the cost that you would have to implement that in production or to run them on your specific cluster or infrastructure. So this is one thing. Secondly, even if we would assume that they are more or less the same, so let's assume that the best query plan that you get from CalSite is indeed the best query plan that would be run on your infrastructure. However, this is not necessarily directly reflected, because when you have the implementation, you still don't necessarily consider the costs, in the sense that, how much memory should you allocate? What should be the parallelism of, for example, a specific operator that you want to implement? These are the kind of, let's say, additional cost optimizations that you can do either at deployment time, so when you have the actual implementation for your query, or even better, you can do them at runtime. So what I want to say with this is that this kind of research and innovation at the area of how do we optimize the Stream SQL or the implementation of Stream SQL to Flink can actually impact the performances that we get, and from that, for that matter, also the costs that we are paying for a specific query quite a lot. So this is, I would say, a very important aspect. It's not something that is so far tackled in the community. I hope together with the community we can drive this part to better optimize the query execution plans. The last thing that I want to conclude with, also as kind of like a vision for the future, is related to IoT. So far, if you think of the way we have approached the usage of Flink, basically, although we say we do the stream processing, which means we have events that come from wherever and we do the processing in real time, we kind of expect that the events are easily arriving into our streaming platform. But if you think of the example with the cars, that all these events are coming from vehicles that are going on a highway or the like. I mean, there is a long way from the vehicle to whatever your Flink cluster where you can do a very optimized implementation. And actually, this is something critical for, let's say, using Flink in IoT scenarios. So basically, how do you transfer the events to your compute engine? And even more, if you think the typical IoT infrastructures, which typically assume that you would have edge devices for the computation, then I'm not sure you always want to transfer everything to Flink or to whatever streaming platform and then apply the filters there. And you say, yeah, I can drop 90% of the data. Are you actually going to transfer 100% of the data when you will use in your analytics just 10%, for example? I mean, of course not. That will be extremely costly. So that means that if we want to really use Flink for such scenarios, we have to think also at a way in which we can either have mini Flink, if you want, that we could run potentially in Flink devices, or some sort of a coordination between deploying some external edge processes of Flink in the edge that are somehow connected with our processing platform. Because if we do not do this, first of all, we will have to build some other tools to do this. Or secondly, or alternatively, it can be that we just need to deploy yet another system to do this kind of processing, and then it becomes arbitrary. What type of processing do you do with Flink? What type of processing you do with another system, and the like. So I think this is also something that us as a community have to think carefully about in order to see what's the best way to proceed in this direction. And additionally, because again I mentioned so much the Stream SQL, I want to finish also with a connection with this. The analytics that you will have in IoT are not necessarily something that are covered by the Stream SQL. So that means that what I have said before, that we need to think of ways in which we can extend the SQL in order to cover more analytics. this is also something needed here. Just think again at the example with the vehicles. You have geographic coordinates and the like. You have to do a lot of, geospatial analytics, for example. This is not something that we have, so this is something that we will have to build. Okay, this is the end of my presentation. Thanks for listening, and of course, if you have any questions about this service, please.
Hey, so I understand correctly that you write those extensions, right, inside of Huawei. For example, the edge computing parts. If I'm right, of course. And if yes, then are you going to share it with community, open source it?
So it's true that we have started to work on some of them, not all of them. And yes, we are hoping to share as many as possible. As I was mentioning also at the beginning of the talk, the strategy is open in the sense that we want to engage with the community. Yeah, I hope basically the vision that we have is something that is recognized by the community as being useful for all the companies, for example, that are using Flink, because it's also kind of like a consensus that you have to reach in order. I mean, I can push a feature or a specific optimization, but if it's too specific to my use cases, it might harm or be inconvenient for others. But yeah, for what it's possible, we are planning to push as many features in the community.
Do you have developer accounts available or test accounts or something like that?
So this is a question for our marketing department. I think we will have, yes. I mean, we can discuss about this. As I mentioned, at this point, the service is in beta release. I think it will go live for everyone in 1 month or so. And yeah, of course, the plan is that we give users the chance to use it. Okay, thank you.